Hello everyone, I am going to make a presentation on Introduction to Sys Safety Instrumented System, and this topic is on Basic Process Control System BPCS. This presentation is being taken on behalf of instrumentationtools.com and automationcommunity.com. Kindly subscribe to the channel. What is Basic Process Control System? A BPCS is an automated control system to monitor and control the process. Under steady state operation, production, all the controls works in automatic mode. Few controllers may be designed to work in cascade. Cascade means one controller works and giving an output to the next controller to act. There may be some requirement. In the process plants, there are several thousands of transmitters which sense pressure, temperature, flow, etc. and several hundreds of valves that operate the process. So all these things has to be operated automatically to have a trouble-free operation, for which the BPCS is being used. Here we are seeing a brief overview of it. There are several sensors and valves, and these are all known as controllers. The BPCS what we are talking of, and it is connected to the HMI network, which is known as human machine interface, from which the operators will operate and control the plant. BPCS takes input from the sensors to provide an output to control valve based on approved design control strategy. Based on the process requirement, the BPCS acts and gives a command. So what are the components involved in the basic process control system? We are going to see about the input-output devices. BPCS receives input from sensors, performs internal processing and calculations in the DCS controller, and then sends output to control valve. Sensors measures the process parameters such as flow, pressure, differential pressure, temperature, etc. Or you can measure current, power, etc. from an electrical switchgear also. Control valve. What for it is being used? It's used to regulate the flow, pressure, temperature, etc. Controller. This is the core topic what we are taking of. It is performing in the signal processing, comparison, mathematical calculations, time delays, etc. as per the logical requirement. For each particular process, there is a requirement which is being developed by the process engineers, chemical engineers during the design of the project, and they formulate a control narrative based on which the logic controllers are working and giving a required command to the valves, control valves, to control the pressure, flow, temperature, etc. The whatever required process parameters according to the process conditions. Okay, here we are seeing a simple P&ID view. How does it look like? For example, this is a HCl tank, for example, and the liquid is being pumped into here, and it is being taken away at the bottom, and it is being sent to a different vessel. Here we are having the level measurement using a level transmitter LT100. This is a technique, and there is a control valve LV100, so which is being used to control according to the level which is being built inside the liquid tank, and then sent to the next process. Maybe a tank, it may be a vessel, or maybe going to some boiler, whatever it is. Okay, and here we are seeing a LC control block itself. It is known as LC100. In pictorially it is represented as a controller. Actually, basically it looks like over here, wherein the controller will be having a power supply unit, a central processing unit having control microprocessor based controllers, and an input model, output model, etc. DCS and BPCS we are talking alternatively, but both represent the same. Basic process control system, cascade control, which I mentioned in the previous slide. Cascade control involves use of two controllers, with the output of the first controller providing a set point for the second controller. The feedback loop for the one controller nestling inside the other. Here just we are seeing a control room look. How does it look like? Basic process control system, HMI. HMI stands for the human machine interface. Basic process control system has an integrated HMI for controlling the plant from a remote location. HMI monitors are provided in the control room. We are seeing a large screen monitors, LCD monitors, and wherein the operators are sitting and operating the plant. These are all part of the DCS itself. Large screen LCD monitors, keyboard, trackball are part of the HMI. Additionally, annunciation windows may be there for alerting operators with an alarm. There could be alarm annunciation windows wherein any particular level of the tank is going high, or temperature getting into a boiler going high, pressure going inside a boiler is going high. Those things will be indicated by an alarm. This is in addition to the monitors which is available over here. HMIs are located in a non-hazardous location for safety of the operating personnel. If you look at the process plants like oil and gas plants, refineries and other petrochemical plants, all the process area is containing lot of hydrocarbons, flammable liquids and high toxic chemicals, etc., which are hazardous in nature. And the operation plant which cannot be in that area, which is a hazardous area. So they are located a bit away from this process area and connected by fiber optic cabling and all. So this is for the safety of the operations personnel. DCS controllers are connected by to HMI by fiber optic and Ethernet communication cables. The controllers will be sitting in a small room besides the HMI area, and a cable will be there from the field to the controller, and then from the controller to the HMI stations. So this is a pictorial view of the DCS system, BPCS system, wherein we have the transmitters as sensors, and a DCS or could be a PLC as a controller, and final control elements are different kind of valves. So we have gone through a basic overview of the BPCS control system.